Hello, hi, this is Sudhanshu. For this POC project, what I have selected is a data set which is a sales data set, and it deals with the customer churn. So this data set is about online sales. As you can see here, this is online sales data where we are trying to predict if the customer will stay or churn out. So here's 1 means the customer churns out, and 0 means the customer stays. So we have to predict which customer stays. So there are various variables which are given here. These are integer variables and categorical variables. The main variables like total purchase, account manager, years, number of sites, onboard date, location, company, and churn data. So what I've done here is done the basic EDA part, which is the going through the head, taking the info. So there are some objects and integer classes. You can see here account manager is an integer class and total purchase is a float. Account manager, though, it is basically 0 1 2, basically these are the number of people handling different customers. So this will be converted to the categorical class later on. In the same way, there are number of sites that will be left as it is, but the location will be dropped because the if you see the address, this we cannot convert into, this is quite complex. Even the onboard date and location, I have left it as it is. I will be dropping it, though maybe it can be used later on in a great depth to try to predict if this makes sense. But as of now, in this data set, we will drop these values. Then after doing EDA and then doing different like seeing the churn data, like what is 0 is 750 and 1 is 150. So we see that there's some data imbalance over here, because the number of customers staying here are larger and the customers churning out are 150 is less. So this kind of data imbalance little bit over here. And then there are different EDA done, and there's a number of sites and count plot, number of sites of visit. Then again this count plot for the churn data, which is pretty much the same thing. And then we also did the disk plot, which basically try to show if this total purchase, age, and years are in a kind of standard normal distribution. We see the total purchase seems like a normal distribution, but still slightly positive is skewed. And then I did some joint plot to see if there is a relation between different age and years of the data. That we find that people between 35 to 50 years are loyal client. They stay till average 3.5 to 7.5 years. Then similarly, we did the total purchase, the number of sites and age. Try to find some data. This is the customer churn for strip joint plot for total purchase and years, and the churn data. So this is churn. Here 1 means who goes out, yellow ones are the one who goes, and 0 are the one who stays. So this data is quite scattered. We can't really predict which people are going out or not going out. But if you see the orange dot, we see more and more customers which have done purchase more than 10,000 and have average 6+ years. We see these guys are not staying with the company. And then there's a categorical data we converted. We check the value counts, we check the we convert these names into categories, location, and the company. So maybe what we can do is also do classification technique and try to see if there's any clustering technique, try to see if there's any clustering we can find, like using hierarchy model. We can see if this makes sense. This company thing can make some sense out of that, but this location and names we will drop. And now going to the box plot, we see total purchase has some outliers, years and age have some outliers. So not necessarily required to do treatment, but I did some outlier treatment here. And then I do this correlation hit plot, which shows there are some no correlation among any variables. Also doing the pair plot, and then doing logistic regression. And doing logistic regression, we find that training and test set that 90% accuracy and 87% accuracy on the test data, and then classification model shows around 87% accuracy and almost 90 plus percent in effort score, recall, and precision. But I also did gradient boosting, and ADA boosting to see if it, something better comes out, or do the result changes if I, uh, do use these techniques. Then what I find is almost a similar performance, 87% and 88% for the gradient boosting, and 87% for the ADA boosting technique. Then I finally use SMOT. SMOT technique I use basically to, to address the data imbalance problem, and then this data imbalance problem, and after this I found the accuracy, slightly lower, 83%. Okay, and then there is a comparison of different models and final conclusion in my report. And this is my report. In this, I have explained, what is the data all about, and my Excel data, and the, head, and then I explain the problem statement, what we need to do here, and then there's evidence of analysis, different techniques which I use, and different plots which I got. I displayed here. And then evidence of analysis, I also showed here the, the logistic regression, prediction, and testing, the accuracies and confusion metrics, classification plot, and the insights from the data that I mentioned here, and demonstrated impact. Sorry. The demonstrated impact, like, we try to show if the customer will stay or not. That the prediction accuracy was almost 87%, to that we can predict if the customer will stay. And this model can be trained over longer period of time with more real-time data, and can be trained to for better analysis. And this is the comparison of all the model which I use, like logistic regression, gradient boosting, ADA boosting, and smart accuracy. And the final conclusion, where I given the, what the techniques used, and what the accuracy received, and and how well the model performed. So this is my final model which I'm going to submit. Thank you.